Bismillahirrahmanirrahim. My name is Raila Iqbal and I am from BS Chemistry Department. The topic of my practical is determine value of lambda max and graph of KMnO4 solution using spectroscopy. Introduction. A spectrometer is an instrument that measures amount of photons, the intensity of light absorbed after it passes through sample solution. With a spectrophotometer, the amount of a known chemical substance concentration can also be determined by measuring the intensity of light detected. Depending on the range of wavelength of light source, it can be classified into two different types: UV visible spectrometer and IR spectrometer. UV visible spectrometer uses light over the ultraviolet ranges 185 to 400 nanometer and visible range 400 to 700 nanometer of electromagnetic radiation spectrum. IR spectrometer uses light over the infrared range 700 to 15,000 nanometer of electromagnetic radiation spectrum. In visible spectrophotometry, the absorption or the transmission of a certain substance can be determined by the absorbed color. For instance, a solution sample that absorbs light over all visible ranges, like transmits none of visible wavelengths, appears black in theory. On the other hand, if all visible wavelengths are transmitted, it absorbs nothing, the solution sample appears white. If a solution sample absorbs red light, it appears green because green is the complementary color of red. Visible spectrophotometer use a prism to narrow down a certain range of wavelengths to filter out other wavelengths so that the particular beam of light is passed through a solution sample. Apparatus: test tube holder, measuring cylinder, pipette, a Lumiere flask, spectrophotometer. Chemicals required: KMnO4, water. Procedure: preparation of 100 ml of a stock standard solution of 0.001 KMnO4. Accordingly, we have 126 milligram solid KMnO4 transferred quantitatively to a 100 ml volumetric flask and filled to the mark with water. This is a stock solution. Prepare 6 standards in 100 ml volumetric flask with concentration of 0.004 molar, solution 1, 0.002 molar, solution 2, 0.0001 molar, solution 3, and 0.0005 molar, solution 4 by diluting the stock solution prepared in step 1, and this is termed as serial dilution. Rinse one of the cuvettes with distilled water and fill it with water. Put the cuvette in the sample compartment. This is the reference solution. Set the wavelength to 400 nanometer, then set the absorbance to 0. Rinse the second cuvette once with distilled water and once with standard solution number 1. Then fill it with standard solution number 1.001 KMnO4. Place the cell in the cell compartment. Measure the absorbance at 410. Repeat this procedure, step 3 and step 4 above, for the two cuvettes at wavelengths 410, 430, 440, 450 to 600 nanometer. First setting A is equal to 0, absorbance for the cuvette with water, then measuring A for the cuvette with 0.001 KMnO4, recording the absorbance at each wavelength, recording data table. Prepare a graph of absorbance A versus wavelength and determine lambda max. Set the wavelength at 550 nanometer lambda max. Place a cuvette with distilled water in the cell compartment and again set the absorbance to 0. Measure and record the absorbance of each of the 6 standard solutions, starting with the most dilute standard. After each measurement, rinse a cuvette with the next standard, not with distilled water. Draw a plot having x-axis as concentration and y-axis as absorbance at lambda max 550 nanometer. Use Beer's law to calculate epsilon for KMnO4 given the cell width, path length to be 1 centimeter. Observations and calculations. This is the absorption spectrum of KMnO4. At 410 wavelength, absorbance is 0.056. At 410 wavelength, absorbance is 0.033. And at 550 wavelength, absorbance is 2.019. This is the absorption spectrum of KMnO4. This is the graph between absorption and wavelength, and the highest one shows the value of lambda max, and the value of lambda max is 550 nanometer. Absorbance of solutions are different concentrations. At lambda max equal to 515 nanometer, concentration 2.5 to 10 power minus 5, then absorbance is 0.033. At 0.0005 concentration, absorbance is 0.186, and so on. This is the graph between absorbance and concentration. This graph shows that greater the concentration, greater will be the absorbance result. The result of the experiment shows greater the concentration, greater will be absorbance. The value of absorbance increases as we increase the concentration of KMnO4 at lambda max is equal to 550 nanometer. Result of the experiment verifies Beer-Lambert's law. Discussion. On the graph, trend line does not pass exactly through zero. This is as expected. It may be due to the statistics of the data point, which are not exactly on the straight line due to random errors in the concentration or on the absorbance reading, or to the fact that there is a diminishing solution absorbance relative to the blank for the standards. Finally, trend line slope is the molar extinction coefficient, molar absorptivity. The equation y is equal to 0.1609x minus 0.1293 for this application should be read as A is equal to epsilon dot C plus constant with the constant equal to intercept. That's all from my side.